Okay, so you guys are going to be doing notes using this Riverboat simulator, and I wanted to walk you guys through how exactly to use it and some of the questions because they are worded a little confusing. So the purpose of this activity, let's get started there, is to analyze the relationship between two vector components of the motion of a riverboat. So on Thursday, we learned a lesson about how vector components can be added up to show the motion of things like planes, swimmers, boats, even animals that aren't going in just one linear direction. So we're going to look specifically at a riverboat today and how those components affect its motion as it's trying to cross a river. So when you visit the link in the agenda to get you to the Riverboat simulator, it should look something like this if you're in the right place. There's a lot of different controls, so I'm going to walk you guys through how to use them. So first of all, we can change the river width by making it smaller or making it wider. We can change the river speed with these arrows on the side. Right now it's 3 meters per second south, but if I hit this down arrow, I increase the river speed even greater in the southern direction. I can also change the speed of the boat horizontally. So right now I'm increasing it, but I can also decrease it if I wanted to and make it lower. I could change the heading of the boat. So right now the boat is pointed directly east or directly to the right, but I can also turn it so it's angled vertically or angled horizontally. What I can't do is turn it around because then it'll go into the bank. So the lowest heading I can have is directly south, excuse me, or directly north. I'm not sure why I did that. Now you can also show the velocity of the boat and what direction it's in and its magnitude, which I highly suggest that you do, because when you change the direction of the boat or the boat's heading, that shows you the vector components of the boat's velocity, which will be very useful. So when you've got all of your settings ready to go, this play button in the upper right hand corner will make the boat actually go. And there's a lot of information that we get from this. So down here at the bottom, it tells you the time it took to reach the other end of the river. It tells you its horizontal displacement, so how far it went to the right, which happens to be the same as the river width, which actually makes sense. It went across the river, so that should be its horizontal displacement. The vertical displacement is about how far down the river the boat went, because it also went down river due to that river current. So they give you a negative displacement just because down normally means negative and up means positive, but the magnitude is really what we're worried about, is that it went down 42 meters. Now, when you're ready to do another trial, you can hit the reset button, and notice what gets reset is really just the boat's position, but your river width stays the same, your speed stays the same, your river speed stays the same. All of these numerical values stay the same. Now, one warning I have for you is be very careful. If you have a great river speed and you have, I don't know, a slow boat or an angled boat and you hit play, look what might happen. See how the boat doesn't reach the other end of the river, but the time still stopped and they still gave you a horizontal displacement and they still gave you a vertical displacement? Be aware that if your boat doesn't reach the other end of the river in the time that you need it to, the program will stop the boat when it leaves the screen, and the time that you get isn't the actual time to get across the river. So this is going to affect some data collection and some of the questions that you're going to have. So once you guys have finished playing around with the controls, you feel pretty confident in that, what you're going to do is you're going to reset the controls so that the heading is due east. And then you're going to go through and complete the procedures and the questions. So I'm going to go back and reset everything. So my boat speed was initially 10. My heading is due east. And now I'm going to, my river speed, I got to fix that. It used to be 3 meters per second. So when I look at my first procedure in question, it says, will the river speed change the time required for the boat to cross a 100 meter wide river? So I need to change this river width to 100 meters. Now, I'm going to let you guys manipulate the river speed and see how it changes the time, but I'm just going to give you some guidance. They say display some collected data. That means make a data table. So record your river speed. Oh, that's funny. Record your river speed. And then record your time. And see what happens to the time every time you change the river speed. For number 2, for constant river width and a due east boat heading. So constant river width and due east boat heading just means that you're not changing the river width and you're not changing the boat's heading. What variables affect the time to cross the river? So I am going to give you a hint right here. There are 2 variables, 2 things that will affect the boat's time to cross the river. So if you're only finding one thing, oh, wait, I think I got that wrong. I did. There's only one thing. I apologize. I'm getting all mixed up. There's only one thing that's going to affect the boat's time to cross the river. So just be aware. I know this line is longer, so it might make you think there's more than one, but there's only one thing. I apologize. So for number 3, what heading will minimize the time? And they say collect some data. Once again, make a data table and show your data supporting your answer. On the next page, this is where you're really going to have a calculator ready to go. You're asked to run the simulation with the following combinations of boat speed and river speed values with a heading of 0 degrees due east. Before running each simulation, perform quick calculations to determine the time for the boat to reach the opposite bank and the distance the boat will be carried downstream. So you're being asked to calculate these values in the table first before you let the simulation do it. So I'm going to show you with our first row how you would go about doing this. So if my boat speed is 12 meters per second, that means my boat is going to go horizontally 12 meters every second. Now, if I know my river width, I know that my boat is going to go horizontally 100 meters. So if I wanted to know how much time it would take to go 100 meters, I could divide it by my speed. I could say, okay, 100 meters, let's see how many times 12 meters goes into 100, and that'll tell me how many seconds my boat is going to be traveling. You could think of this even with dimensional analysis. Your units that are crisscross are going to cancel out. Units that are in the numerator will cancel out with units in the denominator, leaving you with whatever units haven't been canceled out. So 100 times 1 over 12 ends up getting you a time of about 8.3 seconds. So this is hypothetically the value that I should get from the program, 8.3 seconds. So I'm going to put a dash so that I can also record what the simulation tells me. The next calculation I need to do is I need to figure out what distance is it going to go downstream. So this is the vertical or the Y distance that we're talking about. So vertically, my boat is going to be going the same speed as my current vertically. This is your vertical component of your velocity. It's pointing downwards. So if I know that the boat is going to be traveling for 8.3 seconds, and I know that vertically it's going to be going 2 meters every 1 second, I can do dimensional analysis to figure out how many meters does it actually end up traveling. And when I do this, I end up getting about 6.67 meters, something like that. So 16.67 meters is my hypothetical distance that I travel going downstream. So I'm going to go back in my program and test this out. So I'm going to change my boat speed to 12. I'm going to change my river speed to 2, and it's going across 100 meters. It's going east. Perfect. So when I hit play, my time, look at that, is 8.4 seconds. And then my horizontal displacement is, my vertical displacement is 17 meters. So very, very, very close. So they must be rounding their values, whereas I am not rounding my values the same as they are. But at least I did my calculations correctly. So now that you guys have a model for how to do your calculations, I trust that you'll be able to do the remainder of the table on your own. Now, if you filled out this table correctly, going through these questions should be fairly straightforward. I have no doubt that you'll be able to answer these questions looking at your data as long as your data is correct. When you're going through number 6, this is why it's really important you do your calculations for the table. The calculations that you need to do for number 6 are the same calculations you had to do to fill in this table. So pay close attention when you're going through these motions of filling in your table through calculation, and really think about is what I'm doing making sense? Because you're going to need that skill to answer question number 6. Now, moving on to questions 7, 8, and 9. This is your check for understanding for you. So this is your way of, testing yourself to see, did I master what I was supposed to? Did I learn what I was supposed to? Now, the only way that you can know if you've got it right is if you have an answer key to check your answers. So I'm going to post an answer key so that you can test yourself and see, did I get it right? You're going to want to make sure that you're getting that feedback before you move on to the quiz is. Okay, because that quiz is, I'm going to be personally grading your free response questions to gauge your understanding, and you're going to want to make sure you get this practice before you move on to that. So hopefully this video helped you and walked you through the simulator. If you have any